Hello everybody, this is a recording of a way to get the slope of a math graph. As you can see the triangles here, they are always oriented to match the slope of the curve. I'm doing this because I'm working on a flow field or a wind zone in which I want my particles to be flowing along the curve. So it's important for me to know their direction. For this demo, I'm using the math function y equals to x squared. There's a negative sign because in P5, 0 in height starts at the top, not at the bottom. The negative sign there is to reverse it. We can also visualize the graph more clearly in this Desmos graphing calculator. Times a number between 0 and 1 is to squash the curve down so that it doesn't rise too rapidly, which is what I'm doing here. Speaking of slope, if we go to Wikipedia, we can see that slope equals to delta y divided by delta x. That's the definition of slope. And that equals to tangent theta. And this delta y divided by delta x, that's roughly the definition of the derivative of a math function. So if we take the derivative of y equals to x squared, we get k. I'm more used to the k connotation, but if we use the m that we just saw from Wikipedia, it's the same thing. The derivative of that math function is 2x. So knowing the math function, I can get the derivative of it. And knowing that slope from the derivative, I can calculate the angle by taking the arctangent of the slope. So I get this angle value with which I rotate each triangle I draw. There is a plus pi divided by 2 because in P5 I noticed there is often the pi divided by 2 offset for rotation. If I don't put this in, the triangles will be 90 degrees off. I'm not sure why this is, so if you know, I would like to learn from you too. You can comment below. But for this demo, this is pretty much it. Knowing the function of the math graph, we can calculate its derivative. And knowing the derivative or the slope, we can get the angle. It's because of the formula shown in this Wikipedia page. And with the angle, we can calculate how much we want to rotate each triangle.